When I started my career, my mindset was actually stopping me from career growth. I learned it hard way. But today I'm going to debunk all of the mistakes that I have learned so far, and I'm going to share all of them with you in this video. 92% of developers now use AI coding tools. 55% faster task completion with AI and 4 times more output per engineer. This is a data by Stack Overflow Developer Survey 2024. So this actually tells you that what is the importance of the growing technology that you need to adapt. Number 1, the rules changed. Did you? So programming has undergone its biggest transformation since the internet has evolved. Earlier, it used to be that if you know a particular language like Python, JavaScript, then you are sorted. But now it's no longer sufficient on its own. You need to know as a programmer that how system works together. You need to know how to communicate correctly with the AI tools and adapt quickly to the landscape that is shifting. So earlier the core skill used to be memorizing syntax and APIs, whereas now communicating intent clearly to AI system is the most important. Earlier your majorly output was the lines of code that you have written, but now it's like the problem solved per hour. Learning cycle earlier used to be that you have learned one stack and you can keep on working on the same for years, but now every month a new framework comes, the new update comes in everything, so you need to quickly adapt. Value driver earlier it used to be deep language expertise, but now you are expected to work on multiple projects, multiple languages all simultaneously at the same time. Debugging earlier used to be done manually, but now describe symptoms to AI and then we verify outputs. Architecture is a one person's mental model earlier, but now we have composable surveys, AI generated scaffolding. And according to the Stack Overflow Developer Survey 2024, 62% of developers now say that knowing when not to trust AI output is a top professional skill. AI just gives you an output, but you need to verify it, just as important as knowing how to use it. Number 2, prompting is the new programming now. GitHub Copilot users complete tasks up to 55% faster, but most programmers only use 20% of what AI can do for them. The difference between a developer who gets mediocre results from AI versus the one who gets excellent results isn't the tool. It's the way how they actually communicate with that AI. But how do we exactly prompt? So here I have come up with 4 prompting techniques that actually work for you. Technique number 1, context first prompting. You need to give the AI the complete overview of the full stack, constraints and goal upfront. Don't just say that write a function to get a user data. Instead, say it like I'm building a REST API, mention the stack, Node.js, Express, the endpoint is this, need to return the user data with nested order and return early if 404 is not found and log errors to data log. The more context you give to the AI, the better output it will give to you. Technique number 2, role plus constant prompting. So assign us AI a specific role to change its lens. So you can say act as a security engineer, review this authentication function, and you can say that you are a tech manager and how would you actually plan the architecture. Add constants like no external libraries and must run in Python 3.9 to get production usable output immediately. So you just need to give it the limitations as well as you need to confirm it that which role is it working on, experienced, security engineer, data analyst. So you just need to mention that to it. Technique number 3, iterative refinement. AI collaboration is a conversation, not a single query. You cannot give it just a prompt and expect it to give you the best result. It is a like reiteration is the process. So first get working code, then ask it to refactor. Suppose you have a very big functionality to work on. Instead of like explaining everything to it beforehand, what you need to do is just do it in different pointers. So first just give it some point, then you can ask it to refine it, then you can ask it to add validation. So you need to do it in a reiterative process. Technique number 4, verification prompting. So ask the AI to explain its own output. Explain line by line what this function means, then tell me the 3 ways it could fail in production. Through this you can actually get those bugs which you haven't like thought before. Coming to the number 3, that is think in system, not just syntax. Knowing a language gets you hired, but understanding how systems talk to each other makes you actually irreplaceable. By 2025, the most sought after engineers are those who can actually reason about the entire stack. It is not just the code that they write. If you are just limited to one thing only, then you will just stay behind. You need to know how the other things works well with each other. Now there are 4 pillars of systems thinking. Pillar number one is that understand data flow end to end. Trace how a single user action moves through every layer. Like client request is coming, then it is going to API gateway, then it is going to service, then database, then cache, then response. Developers who can mentally stimulate the full path catch bugs before writing a single line of code. So you need to have this kind of view that understand the full data flow end to end. As a practical exercise, draw the architecture diagram of every system you work on, how the data flows, how the journey happens. Pillar number two, learn the contracts between systems, how these systems are connected. REST, gRPC, GraphQL, and message queues, webhooks, each solves a different communication problem. Knowing when to use each is more valuable than mastering any one individual tool. A mismatched protocol is often the root cause of the hardest production bugs. So study HTTP deeply, headers, caching, status codes, and the rate limiting very carefully. Now we have pillar number three, that is get comfortable with failure modes. Every disruptive system will fail. Network partition, race condition, these are not edge cases, they are conditions at scales. So learning patterns like circuit breaker, there are different things which can actually help you catching those bugs, catching those failure things. So eventually consistency separates senior engineers from junior engineer. The best code is written assuming the worst will happen. You need to ensure that what are the different ways through this can actually fail. You need to have that clarity in your mind. Pillar number four, read infrastructure like you read code. So configs, terraforms file, GitHub action pipelines, these are all code. According to a report, 78% of companies now expects engineers to own their own deployment. Understanding Docker networking, environmental variables, and CI/CD pipeline is no longer optional. DevOps territory, it is core engineering. So I'm not saying to just get into each of these fields like very in depth, but you need to have a basic idea of how these things actually works in synchronize with each other. Now coming to the fourth point, the tech stack is moving fast, then you need to move faster. An average major framework releases a breaking change like every 14 months. New AI power tools appear weekly, and the programmers who thrive are not those who chase every trend. Actually, they are those who build a personal system for evaluating and adopting new technologies efficiently. How you can stay at the current without actually burning out, how you can keep up with the technologies coming. Map trends, don't follow them. Read the ThoughtWorks, Tech Radar, there are different publications, states of JS and Stack Overflow developer survey every year. You need to know that what is in trend. You just don't need to just go by the trend only, but you need to access, you need to adapt, you need to trial and see what is actually working, and you need to have that capability to decide it on your own. Build one toy project per new tool. You don't learn tools by reading documentation actually, because you spend one weekend building something small. It could be a CLI tool, a small API, scrapper. If you can't build something tiny in just 6 to 8 hours, you wouldn't use it confidently in production. So the habit of trying something new actually makes you different from others. Then we have prioritized portable skills like SQL, Git, HTTP, regex, and data structures have not fundamentally changed in decades. So these are skills that are not gonna change even in even in like coming 10 years. Docker and cloud fundamentals are also like close behind. So these skills compound over a career. Frameworks may come and go, but the fundamental stays like that only. And embrace the T-shaped model. So go deep in one area, backend, ML, security, infrastructure, but stay wide enough to understand adjacent layers. Like LinkedIn 2024 jobs report names full stack fluency as a number one hiring filter. Companies are looking for people who have the capability to have that overview, have that view that how the different layers comes with each other. Every modern developer should know about these tools, and you should also try to use them. So starting with AI coding assistants, there are around like several AI coding assistants. GitHub Copilot is there, Cursor, Windsurf, Android Studio, there are like multiple. You just need to use any one of them and then you can try out the other, but first get your hands on any one. Then we have infrastructure and deployment. So there is Docker, Kubernetes, Terraform, GitHub Actions, CI/CD pipeline. Infrastructure and deployment related these things you can just get one course that is for beginners. You can try it out, and so that you will get a hold of how these things work. You don't need to do a very detailed course of like 100 plus hours, but you just need to know that what are these actually. Then you have the debugging and observability tools. So Datadog, Grafana, and Postman for testing APIs. These also you can explore. And then you have testing like jest with test, you can do unit and integration testing. And developers who write tests ship 40% fewer bugs. This is also done in a report. So these things are actually required. You can test on all these things so that you will get a. So now coming to the skills that can actually get you promoted. Technical skills gets you in the room, they get you hired, they get you a job. But after getting into that job, how quickly you actually like how quickly you ascend the ladder of promotion of success, that depends on these skills. So we have this four non-technical skills with great impact on your career. Firstly is write clearly. So best engineer, if you know how to write clearly your things, you can communicate the best with AI assistants, with AI code. And a well written proposal gets approved, vague one gets ignored and delayed for weeks. Written communication multiplies your impact across time zones. So be specific about the why, not just the what. Scope and estimate accurately. If a client comes to you, if your TL comes to you and ask for the time and estimation, you break down works into tasks, identifying like what you have done in the past, how much time it will take. If you're not sure, you can always take the help of chat gpt or AI. So you just need to give the estimation instead of saying it will take time, or like giving it vague answers. You need to scope and estimate the things. You need to like handle it, you need to plan it better. Ask better questions before writing code. Confirm the actual problem. If you have identified, if you say the problem out loud like in a very clear manner, you are already like 80% done with the solution. So this thing you need to build within yourself. And do thoughtful code reviews. Thoughtful code reviews actually focused on learning and clarity, not criticism. And how engineers multiply the team entire output. Organization with strong review culture actually ships 40% fewer bugs, as we already discussed. So now what should be your action plan starting this week? First thing you need to do is to set up an AI coding assistant. It could be Cursor, Copilot, similar, and draw the full architecture diagram of the last system that you have worked in. How different data flowed, how what was the user journey, how the data was flowing in the backend, where it was going, what tools were being used. Read the Stack Overflow surveys and ThoughtWorks Tech Radar, so it will actually help you to know what is going on in the industry. Build a personal prompt engineering cheat sheet for your domain. You can for example do 10 prompts I use every week for debugging React, and share it with your team. Contribute to any open source project, even a documentation. Then you deploy a small application end to end on a cloud provider. So deployment is also very important, because AI, you cannot trust AI completely over that. For writing code, obviously we get it done through AI, but deploying is one thing that you need to have a command CI/CD pipeline you can learn. And ultimately you will become the developer who cannot be beaten by AI. So that is it for this video. If you liked it, then please like and subscribe to this channel.